Hey, welcome. Have you ever looked at a piece of software and just thought, wow, this just works? What is it that separates the good stuff from the truly great? Well, I'll tell you, it's usually not about some genius line of code. It's about the secret blueprint, the plan that's made long before anyone even thinks about coding. And today, we're going to pull back the curtain on that blueprint.
So let me just ask you right off the bat, what do you think is the most important part of building software? Is it the coding itself, the testing, the cool user interface? It's a really interesting question, and the answer gets to the very heart of what it means to make something people actually want. And the answer really comes down to this one crucial difference. On one hand, you have building it right. Writing clean, fast, elegant code. That's super important, obviously. But on the other hand, you have building the right thing. And that's all about making sure you're solving the actual problem for the user. Because let's be honest, you can write the most brilliant code in the world, but if it solves the wrong problem, it's completely useless. So let's start at ground zero. Section 1, the idea and the problem. See, every amazing app or program you've ever used didn't start with a brilliant solution. No, it started with someone having a really clear understanding of a problem that needed solving.
This all gets boiled down into what we call a problem statement. You should think of this as the project's North Star. It's not a big long list of features. It's just a short, sharp, crystal clear description of a user's pain point or need. Getting this statement right from the beginning, well, it's everything. It's how you avoid spending months building something nobody actually needs. Okay, let's make this real. Imagine someone says, let's build a university registration system. Sounds pretty straightforward, right? But then you start thinking about it. What does that even mean? Does it include browsing courses, registering? What about paying fees or scheduling exams, or even room allocation? The initial idea is almost always this giant, fuzzy cloud of possibilities.
And that's why this next step is so critical. You have to narrow the scope. You have to decide very deliberately what your system is not going to do, at least at first. So for our system, maybe we say, you know what? No fee payment for now, no room allocation. By striking those out, we suddenly have a focused, achievable project. We're drawing the lines and defining the edges of our blueprint.
All right, once we know exactly what problem we're solving, we need to understand the world that problem lives in. Think about it. An architect would never design a house without walking the land, checking the soil, seeing where the sun rises. Well, we need to do the same thing for our software. We call it domain analysis.
So what is domain analysis really? It's basically the process of becoming a temporary expert in your user's world. It means you've got to learn their lingo, their daily workflows, the little things that drive them crazy. You simply can't build a great tool for a job you don't truly understand.
And why bother with all this? Well, it pays off big time. When you know the terrain, you build so much faster. The system you design is just plain better because it actually fits into the real world. And here's the kicker. You can even start to anticipate what they might need next, and you can plan for those future additions right from the start. It's just smart.
Okay, so we've nailed down the problem and we've surveyed the land. Now, here in Section 3, we can finally start drafting the actual blueprint. In the world of software, we call this defining requirements.
So a requirement is just a formal statement about what the system has to do, or a rule it has to follow. But pay attention to that last part on the screen, a negotiated agreement. This is so important. A requirements list isn't just some technical document. It's a handshake, it's a promise between the people building the thing and the people who are going to use it.
Now, these requirements come in two main flavors. First, you have functional requirements. These describe what the system does. For example, the system must let a student register for a course. Simple enough. But then you have quality requirements. These describe how well it does it. For example, that registration page must load in under 2 seconds. You absolutely need both to build something great.
So, how do we actually find out what these requirements are? Well, we've got a whole toolkit for that. You can literally go and watch people do their jobs, just shadow them. You can interview them and ask about their vision. You can get a bunch of people in a room and just brainstorm ideas. Or, and this one is super powerful, you can build little prototypes, just simple mock-ups to get feedback before you're committed to a design.
A blueprint is awesome, but it's also kind of flat and static, right? To really understand how a house will feel, you need to imagine people actually living in it, walking through the halls, cooking in the kitchen. In software, we have something just for that. They're called use cases. A use case is just a simple story.
It describes the step-by-step process a user goes through to get something done, and it's always told from their point of view. This little trick completely changes the game. It takes all those abstract requirements and turns them into a human story, making the user the hero of the design.
And you know what? These stories can be incredibly simple. Just look at this classic example for open file. It's just 2 columns. On the left, you've got what the user, the actor, does. They choose open, they type a file name. On the right, you have how the system responds. A dialog box appears, then it disappears. That's it. This simple little script removes any and all confusion about how a feature is supposed to work.
Now, to keep these stories organized, we use a few clever tricks. The first is called generalization. The easiest way to think about this is like a category. So open file is the general idea, the main category, and underneath it you might have more specific ways to do that, like open file by typing name.
Next up, we have an exception. This is our tool for handling all the what-if scenarios. What if the user tries to open a file that doesn't even exist? Instead of cluttering up our main happy story, we just define that exception as an extension. It keeps the main path clean and easy to follow.
And finally, there's inclusion. This one's all about being efficient and not repeating yourself. If lots of your user stories need the person to browse for a file, you just write that little sequence once, and then you can include it wherever it's needed. These 3 tools, generalization, extension, and inclusion, they let us build a whole library of user stories that's clear, powerful, and easy to manage.
And that brings us to our final, and maybe most critical, piece of this whole puzzle. Here's the big difference. A blueprint for a building is set in stone. But a blueprint for software, it's a living, breathing document. It absolutely has to be designed to change and adapt.
And why is that? Well, because the world doesn't stand still. Business needs change, technology gets better, and honestly, the deeper you get into a project, the better you understand the problem you're trying to solve. So change isn't a sign that you failed in your planning. It's just a natural, inevitable part of the journey.
But, and this is a big but, managing that change requires real discipline. I absolutely love this quote. Avoid making the system bigger, only make it better. The goal is always to refine and improve the solution you're building, not to just keep piling on more and more features. That's a trap called scope creep, and it's a project killer.
Which kind of leaves us with one final thought to chew on. If we know for a fact that the plan is going to change, then maybe the most important skill isn't creating that one perfect, flawless blueprint at the very beginning. Maybe the real genius lies in knowing how to gracefully and intelligently adapt that blueprint as the project comes to life. What do you think?